Hello and welcome all the viewers. I Ms. Rupali welcomes you all on my YouTube channel, that is Bhumi's Physics Tutorial. So we have started with Unit 2 from the basic science, that is electricity, magnetism and semiconductors. Today we are going to learn another most important topic from the electricity, that is electric field. सो फील्ड ये जो वर्ड है इसका मतलब हमें पता है, ओके, दैट इज़ नथिंग बट द स्पेस. एंड इलेक्ट्रिक इट इज़ रिलेटेड टू द चार्जेस. ओके, सो we can define the electric field as the space around an electric charge in which its influence can be felt is known as the electric field. Now it is said that the space around an electric charge. Now this electric charge may be positive charge carrier or the negative charge carrier. Now the space around this electric charge, okay, and till a particular distance, the influence of electric charge can be felt is known as the electric field. Okay, got the meaning of electric field? Or else we can also define electric field as the force experienced by a test charge in presence of the given charge at the given distance from it. So we have seen in the Coulomb's law also that whenever there is a presence of charges, they exert a force on the other charge. Okay, so मान लो मैंने एक positive charge consider किया है who produces or who is the source of the charge, and in the surrounding of that charge I place another charge which I can call as the test charge. Okay, why we are calling that as a test charge? Because we are using that charge to feel the electric field which is produced by the source charge. So the source charge will exert a force on the test charge. Okay, so the field in which the force is experienced by a test charge at a particular distance is known as the electric field. Now this test charge is a positive charge. Conveniently इसको positive charge ही consider करते हैं, which is so small in magnitude that it does not affect the surrounding of the given charge. देखो, there are two possibilities. One है ये पॉजिटिव चार्ज है विच इज़ द सोर्स चार्ज. ओके, नाउ दिस इज अ पॉजिटिव चार्ज. ओके, नाउ इन इट्स सराउंडिंग आई हैव प्लेस्ड अनदर चार्ज विच इज ऑल्सो पॉजिटिव चार्ज. ओके, now as both are the positive charge, obviously there is a repulsion, and that repulsion is because the source charge is exerting a force on this test charge. Now these two charges are separated by a certain distance. They are not bound to each other. Okay, they have certain distance between them. Now this is about the positive charge. Okay, so if I'll place the positive charge in the surrounding of the source charge, then the direction of the force is in the outward direction. Okay, and this test charge will feel the electric field that is also in the direction of the force exerted by the source charge. Now if I'll place a negative charge in the surrounding, then yes, there will be the attraction. Okay, and the force is in the inward direction. So this you have to keep in mind, and that's why conventionally it is considered that test charge, it should be positive, and that is too small in magnitude that it does not affect the surrounding of the source charge. Okay, now how to represent the electric field mathematically? So ये जो electric field है, mathematically it can be defined as the force experienced per unit charge. और ये force कौन exert कर रहा है? The source charge. Okay, so source charge obviously it is going to exert a force, and force कौन experience कर रहा है? तो वो test charge. Okay, so mathematically we can define electric field as the force experienced per unit charge. Therefore we can write E, which is the strength of the electric field, which is equal to F stands for the electric force upon Q. I can write here small q as the test charge which is being used to feel the electric field. And the unit, the SI unit of electric field is Newton per Coulomb, because the unit of force is Newton and charge unit is Coulomb. Okay, got the point? Now let's see the next. The electric field exists around a charge irrespective of the presence of the other charges. ये भी आपको ध्यान में रखना है कि yes, there is existence of the electric field, though there is a presence of other charges in its surrounding, that doesn't matter. Now, since the Coulomb's force is a vector, this electric field is also vector quantity. Okay, electric field is also vector because force is also a vector quantity. ये भी आपको ध्यान में रखना है. Why? Because force, the Coulomb force, that has magnitude as well as direction, and therefore electric field will also have magnitude as well as direction. One more point you have to keep in mind is whatever is the direction of the force, that is the direction of the electric field. So positive charges के बारे में electric field की direction outward होगी. Okay, when we are considering the source charge as positive, and it will be negative when the test charge is negative. Okay, source charge आपका positive ही होने वाला है. So at that time the direction of electric field is inward. ये दोनों आपको ध्यान में रखना है. पॉजिटिव चार्ज होगा तो आउटवर्ड होगा, नेगेटिव चार्ज होगा तो इनवर्ड डायरेक्शन होगा. ओके, नाउ we'll find the electric field due to a point charge which is plus q. Okay, तो यहाँ पे आपको दिख रहा है कि this is plus q we have considered as a source of electric field. Okay, this is source charge. Now ये जो आपको circle दिख रहा है, okay, so you can place your test charge anywhere on the circumference of this circle. You will get the same electric field over this circumference irrespective of the position of that test charge. आप यहाँ पे भी रखते हो, यहाँ पे भी, wherever you can place the test charge, the electric field is same everywhere. तो for now just see, ये electric field की direction है which is in the outward direction. यहाँ पे on the circumference you can place the test charge, and the test charge and your source charge there is a distance of r, okay, between them. Now, what is the electric field produced due to this point charge that we are going to find now? So let consider that capital Q, which we have considered as the point charge, and Q, which is the test charge here, be the two charges which are separated by a distance r. Then according to the Coulomb's law, we know that Coulomb force between the two charges, that is F, which is equal to K, and the value of K we know, that is 1 upon 4 pi epsilon naught epsilon r. Okay, epsilon r is equal to 1, that we know. Product of magnitude of the charges divide by the square of distance between them. So ये Coulomb law जो है, that we have already seen. So according to the Coulomb's law, we got this, okay. And we know the formula of electric field, which we have seen right now, that is electric field is equal to force per unit charge. So in this formula, we will just substitute the value of, so on substituting the value of force in this formula of electric field, what we got is the 1 upon 4 pi epsilon naught q upon r square into q. So both the q's will get cancelled, and what is remaining is electric field is equal to q upon 4 pi epsilon naught r square. Okay, now here this is the expression we got for the electric field. So from this we can say that electric field depends on the source charge as well as the distance between the source charge and the test charge. This Coulomb's force acts across an empty space, that is vacuum, and it does not need any intervening medium for its transmission. Okay, and therefore we can say electricity can pass through the vacuum also. So the magnitude of the electric field at a distance r from a point charge q is same at all the points on the surface of the sphere of radius r. Okay, the first figure which we have seen, कि on the circumference of the circle, wherever you will place the test charge, everywhere the magnitude will remain same. ये आपको ध्यान में रखना है. And its direction is always the radius of the sphere pointing away from its center if the charge is positive, and if the charge will be negative, then it is directing towards the center. तो ये दो चीज़ें आपको ध्यान में रखने. तो this is about the electric field. Now, what is the electric field intensity? Okay, intensity मतलब हम बोलते हैं ना कितना इंटेंस है, मतलब कितना तेज़ है और कितना कम है. ओके, सो वी टॉक कि लाइट की इंटेंसिटी कितनी है. ओके, लाइक दैट देयर इज़ अ intensity of the electric field also, and obviously that will depend on the distance. जितना ज़्यादा डिस्टेंस बढ़ेगा उतना उसका फोर्स कम हो जाएगा, एंड इन दैट वे उसकी इंटेंसिटी जो है वो कम होती जाएगी. लाइक अगर कोई बल्ब है वो ग्लो कर रहा है, सो आप जितना उसके नज़दीक जाओगे उतना आपको ज़्यादा वो इंटेंस लगेगा लाइट, बट एज यू विल गो अवे फ्रॉम इट द लाइट बिकम्स लेस इंटेंस. सो सेम है इलेक्ट्रिक फील्ड इंटेंसिटी. बिकॉज ये तो स्पेस ही है ना अराउंड दैट चार्ज. सो जितना आप ज़्यादा दूर जाओगे उतना इंटेंसिटी क्या है, कम कम होते जाने वाली है. सो ये इंटेंसिटी मतलब क्या है? सो इट इज़ नथिंग बट द फोर्स विच इज़ एक्सपीरियंस्ड बाय द यूनिट पॉजिटिव चार्ज विच इज़ प्लेस्ड एट अ पर्टिकुलर पॉइंट. तो यहाँ पे मान लो कि Q ये एक चार्ज है, ओके, यूनिट पॉजिटिव चार्ज which is placed at a point O. So it is the source of the electricity, or the source charge, we can say, call it as a source charge. Another charge will keep in the surrounding of the source charge, which is Q naught, which we have placed at a point P. And both these charges are separated by a distance R. Then what is the intensity that we will find? Okay, so let's see the electric field intensity due to a point charge. So for that, consider a point charge as Q, which is placed at point O. Consider the point P in the electric field of point charge at a distance of R from Q. A test charge, this is Q naught, placed at the point P will experience a force which is given by the Coulomb's law, जो हमने पहले भी देखा है कि जहाँ पर भी दो चार्जेस आ गए वहाँ पे क्या है, Coulomb's law एप्लीकेबल होने वाला है. Because these two charges, they are separated by a certain distance, so each charge is going to exert a force on the other charge. So we'll apply the Coulomb's law over here, and that will be force, which is a vector quantity because it has a direction as well as magnitude, which is equal to 1 upon 4 pi epsilon naught k q0 upon r square. And we know by the definition of electric field intensity, E is equal to F upon Q naught. Q naught ही क्यों consider किया है? Because we are finding the electric field intensity at point P. Okay. And therefore what we got is 1 upon, just by substituting the value of F over in this formula, we get it as 1 upon 4 pi epsilon naught k q upon r square. So the direction of electric field will be along OP like this, okay, when Q is positive, and it will be negative, then the direction will be like this. ये आपको ध्यान में रखना है, okay. Then the magnitude of the electric field intensity in a medium, yes, that is E is equal to 1 upon 4 pi epsilon naught. K is equal to 1 for the vacuum. Therefore, we have replaced that into Q upon R square. So, the Coulomb force between the two charges and the electric field E of a charge both follows the inverse square law. ये आपको ध्यान में रखना है, ओके. So this is what about the electric field and electric field intensity. If you like the videos, please do share with your friends. Press the bell icon for the new updates. Thank you.